All right, good afternoon, everyone. I think we should get started. I'd like to welcome you to today's webinar, which is Putting Transparency in Motion, How to Produce an Environmental Product Declaration for a Whole Train. Today's session is part of ThinkStep's webinar series, Straight from the Horse's Mouth, Insight from Experts in 30 Minutes. My name is Jeff Vickers, and I'm joined today by Elise O'Sullivan, Environmental Sustainability Manager for Rolling Stock from Downer Group. So welcome, Elise. And also a warm welcome to the rest of you. It's great to see so many interested companies on the line. So I'd just like to get started today first by talking a little bit about what an environmental product declaration is, before I hand over to Elise to talk about why Downer produced one and sort of the process that we went through to get there. So an EPD, or an environmental product declaration, tells the environmental story of your product over its full life cycle. They're often compared to a nutrition label, where you look at, instead of grams of fat or sodium or the kilojoules in the product, you're looking at carbon footprint, the water intensity, energy intensity over the life of the product, and not just what's physically in the product, but also what goes into it, making it upstream, and also what happens further downstream at the end of life. An EPD is accurate, it's independently verified, and it's globally recognized. The standards for EPDs, ISO 14025, and a lot of the specific rules that we follow are very global in scope. An EPD demonstrates your commitment to sustainability as an organization, and it helps to boost your environmental credentials. And when we get into some of the slides later on, at least we'll cover that in a bit more detail. So a very quick overview of how you might go about producing one. Basically, you start by selecting a set of rules known as a product category rules, or PCR. The PCR allows you to make fair comparisons, and the image there is showing just an apple and an orange, because we want to compare apples with apples, oranges with oranges, and that's what the PCR lets you do. Once you've got those rules set down, you then conduct an environmental life cycle assessment to assess the sustainability of the product following those rules. You generate the environmental product declaration itself, which is a relatively short version of the life cycle assessment. But there's also a very detailed report known as a background report or project report that sits behind that. And both of those two things get verified by an independent accredited verifier that's associated with the EPD program you're producing your declaration under. And then finally, you publish that declaration so it's available for consumers and for the general public. So I'm just now going to hand over to Elise to talk a little bit about more why Downer created them and some of the process that we went through. So over to you, Elise.
Thanks, Jeff. So why create an EPD? I think it's really important to first address sustainability in a global marketplace, because that helps inform why anyone would really embark on an EPD process as a company. So from the top down, the UN Sustainable Development Goals provide the blueprint for a sustainable future, which addresses the global, regional and local challenges faced, including those relating to poverty, inequality, climate change, environmental degradation, prosperity, peace and justice. The production of an EPD for rolling stock assets aligned to the Sustainable Development Goal number 9 being industry, innovation and infrastructure. Number 11 being sustainable cities and communities, and then number 12, the responsible consumption and production. When we consider the global goal framework, including the Sustainable Development Goals, we can start to appreciate that for ASX listed companies and investors are increasingly asking companies like Downer, what are we doing in the space of sustainability? Environmental product declarations contribute to such portfolios, being the portfolio of sustainability, with alignment to the expectations that investors are increasingly having as a result of increasing awareness of their part to play in a global context. We are seeing and hearing from our clients about more and more requests for lifecycle assessment data as part of project and tendering processes. Companies, they're starting to also push on those requirements through their supply chain and requesting some of this information as well. Even when there is no formal request, a lot of our clients are providing this information proactively. By putting the environmental product declaration into the tender or into the project requirement, they are also using it to show a commitment to transparency within the industry and providing credible science-based data. You can see that the main reason companies are now going down a green building path, or similarly an EPD path, is more centered around client demand and less based on regulations. And we definitely see a similar driver occurring behind the requirement or the request for environmental product declarations as too. EPDs can also be used as a great marketing tool as well. So how to create an EPD for rolling stock? Not easily, but not impossible. When we embarked on this process, what we were confronted with is over 150,000 parts or components that make up an 8-car set rolling stock. That also comprises 500 tonnes of materials. Ultimately, we required the import and assistance of 5 parties, 5 key party areas as part of that process. So obviously Downer, thinkstep as our lifecycle analysis partners, CRRC as our major manufacturing partner, and then also our own in-house engineering team and environment sustainability teams. 2 use phase scenarios were actually modelled for the application or the use phase application to the EPD. We were able to obtain 12 months of real energy data to also put some real data rather than simulated modelling data into the EPD LCA. And it took us 13 months from kickoff to publication to complete the process. To recap what Jeff just touched on before, an EPD is a registered document that provides a transparent and comparable information about the life cycle impact of a product or an asset, in this case being rolling stock. All the information that goes into an EPD is independently verified, and then it's completed in accordance with the framework that you can see on the screen, consisting of the ISO standard, the International EPD PCR, the EPD background report, and the actual registered document, and then finally your independent verification. The issue with that framework as it is there is actually more to it than meets the eye, and that was definitely our experience. And we were able to derive what we believe is a pretty simple analogy to explain that. So it's basically a barbecue analogy, which is you're going to have some mates around your place and you're going to host a barbecue. This is one of those barbecues that you're actually going to cook. You're not going to cheat and buy pizza or something like that. And the catch is you're going to have a food critic that wants to come and will hopefully at the end of the evening or the end of the experience award you the best backyard barbecue for 2019. So considering the images that you all see on the screen, if all you have is the ISO standard or what we call your draft menu, so that's your salads, your meats, your dips, your bread rolls, your drinks, tick all those boxes, happy days. If also all you have is the PCR, which dictates the content of what is required and how it must be formatted. So similarly, the PCR would be having some guests that have some dietary requirements that need to be factored in as well. Lactose intolerance or something like that. It's the framing of those real specific rules about how things need to be done as part of the process. If all you have is the EPD or the LCA background report, which is the equivalent of your cook, your plate up and you serve to your guests, and then your independent verifier or your food critic, which deliberates, critiques your efforts and then awards your event. If all you have is that, do you think it's actually enough to put on an award-winning food critic barbecue? The answer is no, but why? Because you're missing a shopping list and the instructions of how to cook, ultimately. If you can't cook, you can't cook if you don't have the ingredients, and you can't figure out your ingredients if you don't know the steps required to achieve your menu, including the dietary requirements. So before you can perform the life cycle analysis, you need to compile all the data sets or, as I said, your shopping list. This is something that websites on an EPD process actually don't really address and talk about, but definitely from our experience, we saw this as the most critical step to actually being able to undertake and complete this process. So your data sets for rolling stock included the bill of materials. So again, it's a bit like your shopping list. It's your full list of ingredients that go into making a train. Your maintenance schedule, so how often are you going to maintain it? How often are you going to do an overhaul? Those sort of engineering requirements. Energy consumption, so as it's implied in the term, how much raw energy does it take to drive a train, but then also to run the maintenance facility, to then service the train, so on and so forth. Your use phase scenarios, and then your end of life management plan. So what do you plan on doing with the asset once it's met the end of its life? If we then touch on the bill of materials, with the PCR, it's one thing to take the bill of materials, or as I said, those ingredients of making a train, but it's actually another thing to then apply the PCR categories. So it's not as simple to say that, the car body shell is made of steel. You need to then define it into the content of stainless steel, carbon steel, and aluminium, zinc, whatever the content is. So getting that extra level of granularity does present its own complexities, particularly if you're deriving the information based on paper sources or paper design as opposed to electronic design. So we did find that during our experience, there was certain streams of ingredients that were quite easy for us to achieve the PCR breakdown, but then there was others that we needed to really go back to the drawing board and further refine exactly what the material composition was. Maintenance schedules, thankfully Downer has been in the rail industry for quite some time in Australia, so it's something that we understand quite well. We do manage 3 fleets in Sydney alone, so maintenance schedules, we were quite comfortable with that data. And then obviously the manufacturing data, we need to work closely with our partners to obtain that data set as well. Jeff, I'll just hand back over to you.
Thanks, Elise. So, clearly with any kind of energy-using product like a train or a large train set, typically speaking, the use phase will be really important. And the chart that you're seeing on the right is just showing all the different sort of energy that's being tracked as part of the train set itself. So the traction energy to move it along, the regeneration for regenerative braking, which is shown here as a positive number, which is actually taken away, the heating and cooling, the HVAC load there, and also the auxiliaries like lighting and doors opening and closing and that kind of thing. So we were really lucky in doing this particular project that we had a lot of good data. Often when you're building a new train, you're going to be using simulations, but thankfully this is there's already existing data for the network for a similar train set, which enabled us to be able to get really good heating and cooling data, for example, which you wouldn't otherwise have. And so that enabled us to really look at, okay, what does real look like on the network? What are real passenger loads? What are real journey lengths? What are real heating and cooling demand over the last calendar or financial year? So it gave us a really great idea of what actually happens rather than just taking a simulation. But when you sort of do start to make these calculations, you also have to decide on which passenger loading do we actually want to standardize around. Is it the maximum seated load of the train? Is it the maximum capacity including people standing? Is it some variant other than that? And that's where the product category rules can really help to set some of those sort of core requirements. And also we have to define what we expect the life of the asset to actually be. And so if you go through the environmental product declaration, you'll see some of these things laid out. So you can see, as Elise mentioned before, we've got 2 scenarios. We've got the kind of nominal capacity and we've got the fully loaded scenario to give you an idea of how the train performs in each case. And what you can see is in both cases, we've got a 30-year service life. In both cases, we're traveling the same distance, but the key difference is that the average passengers per train is obviously quite a lot different. And so 2150 is basically the capacity of the train. So if we're operating in that full load scenario, what does that mean? The load factor is above 100% just because of how it's calculated, but that's effectively giving you an idea of fully loaded versus another alternative scenario. And then here you can see we've calculated through what is the average electricity consumption per kilometre and per passenger kilometre. And for those of you who know life cycle assessment well, you'll know that there's this core idea of the functional unit, so what it's all related to. And in the case of a passenger train or passenger rolling stock, we're really interested in transporting people. And so in this case, we're looking at transport of 1 person for 1 kilometre, so a passenger kilometre. And we're basing the EPD around a set configuration. So this is an 8-car configuration, double-decker train, expected service life of 30 years. And considering that full life cycle performance, again, looking at manufacture, transport to market, the actual use, operation, maintenance, and then finally the end of life after that 30-year period, and trying to relate all of that back to 1 passenger kilometre to make it meaningful. And when it comes to end of life, if you've got a lot of materials coming in and a very complicated bill of materials, you've also got to deal with that same complexity when you come to recycle the train at end of life. And so what we relied on was the Unify recycling and recoverability method, which is sort of required or strongly encouraged under the product category rules. Unify is a European rolling stock manufacturers association, and they've based their method heavily on the end of life of vehicles and recycling and landfill and incineration rates for vehicles. And so what this method does is it sorts the train into different material types, and then we specify a fate depending on that material type. So how much goes to landfill, how much goes to recycling, how much goes to incineration. And in the incineration context in Australia, we've just assumed that goes to landfill as well, because we don't have the same incineration as you would have in Europe. And so this really helps to standardize the end of life approach. It's not necessarily perfect, but it gives you a concept of what might happen 30 years from now. And so when we come to, what does this all mean? What are the results? What you can see and what we kind of expected from the outset is that the use phase is dominant. So you can see four different environmental impacts there. GWP is global warming potential or carbon footprint. EP is eutrophication potential. AP is acidification potential, and POCP is the very sexy photochemical ozone creation potential. It's summer smog. So it's basically carbon, it's nutrient loading in algal blooms and waterways, it's acid rain, it's summer smog. Those are the four indicators there. And you can see it's been broken down into a stack bar by the materials, the manufacturing, the use and the disposal. And the yellow bars are really dominating there, and pretty much nothing else is getting a look in. And that's just the nature of the asset type, heavily utilized, long life, and used kind of towards its maximum capacity to get the most out of the asset. But as an electric train, one of the things that's interesting is that clearly that use phase is also heavily dependent on the region you use the train in, and also which year you're talking about. So this particular train set's used in New South Wales, so you can see there the New South Wales grid mix. We've also got Northern Territories, Queensland, South Australia, Tasmania, Victoria, and we looked at a range of different options just so that you could see the relative differences in performance and also start to make comparisons between this particular asset and also similar ones overseas, because there are certainly EPDs for trains, and you can't really make a fair comparison in a different country where the grid mix is entirely different. But luckily, it's relatively easy to adjust this, which is what we've been doing here. And of course, on the far right hand side, you can see that passenger loading is everything. So obviously something like this is going to perform its best when it's loaded most, and so you can see that that's showing carbon footprint, but you can see that it's really decreasing significantly as you approach the maximum loading of 2150 passengers. And when you've got a very low loading rate, you're using a lot of carbon, or there's a large carbon footprint associated with that per passenger, because you're moving a train with no people in it. So the interesting thing about all of this is that it shows I think the potential that the network operator has to, and the importance on maximizing utilization, either through appropriate timetabling or running smaller services with fewer carriages, for example, or whatever it may be. And it also shows the incredible potential through decarbonizing the grid mix, because obviously if you could move from, say, a New South Wales grid as shown here to, say, the Tasmanian case, you're more than halving the environmental impact or carbon footprint of the train over its life. And that's something that certainly would be aspirational for the state, but also for just more broadly would have a huge impact on the final outcome. And with that, I think I'd like to hand back to Elise to cover some of the lessons learned through this process.
Sure. So the first point I make is tender costing for EPD, and making sure that you actually appropriately provision the amount that you'll need to actually facilitate this process. But the key to remember here is rolling stock is rolling stock. And the reason why I say that is I've been asked ever since we completed the heavy rail rolling stock EPD, how much would it cost to do a light rail one, or how much would it cost to do a different set all over again? But ultimately, if I look at the process itself, we're applying the PCR to an 8-car set, but each of the data sets is actually only addressing one car, and then we extrapolate it out. So based on that, whether it's one double-decker EMU, or it's a 1-car set for a DMU or a single level EMU, it really is the same level of effort required, and oddly enough, the bill of materials is probably just as long. So I don't think it's something to be feared. It's just something that should be considered upfront if it's possible, and therefore costed appropriately. And that includes provisioning of time as well. If you did want to be able to complete an environmental product declaration for rolling stock, the key is to start early, particularly during manufacturing phase. If you leave it too long after provisional acceptance of the rolling stock into the network and it starts being operated, you will find it increasingly more difficult to have those close touch points with the manufacturer or with the key engineers that are leading the project to be able to refine those data sets to ensure that you can achieve the EPD in a timely manner. It's not to say that it can't be done. It just may present itself with its own unique complexities if you do delay the commencement of it. Data sets to be completed before the rolling stock arrives, that's just based on our own personal experience when we embarked on this process. Once the rolling stock arrived, it does go into testing commissioning. It does mean that a lot of your resources are quite stretched and they're very focused on obviously achieving provisional acceptance of the rolling stock. So that way it can start servicing, ultimately the passengers and customers who want to enjoy the experience. So definitely focusing on those data sets before that rolling stock arrives and before it enters testing commissioning phase is definitely ideal. Early consultation with project director for images. It was an interesting one. In our experience, unfortunately, the minute the train went through testing commissioning phase, it did become quite difficult to obtain images to finalise the environmental product declaration and be able to send it for independent verification. So definitely working with your project director to identify as early as possible the windows of opportunity to have those images taken for the finalisation of the final EPD, and nice glossy brochure is definitely encouraged. Take the customer on the journey, so make them aware of exactly what the processes are that you're undertaking and the level of effort at times that is required to complete and facilitate the environmental product declaration. And an EPD for a rolling stock is, as could be assumed, complicated. It is very time consuming. It was difficult and definitely a challenge, but it was worth it. And definitely keeping your customer or your client abreast of that experience where you can would be strongly encouraged. Embrace the challenge and seek the opportunities. This was definitely, as an environmental sustainability professional, being my day job, I don't typically dive into the intricate details of rolling stock. This process definitely has taught me things that I wish I could now forget about a rolling stock fleet, but it was definitely worth it. And you will be presented with many an opportunity where, you'll need to work quite closely with your engineers to find the right data set and refine it in a way that it's going to achieve the PCR and therefore achieve that end goal, which is having a verified EPD.
Thank you very much, Elise. So just to, for those who may not have seen it yet, you can go and download the EPD. It's publicly available now, so just put a link up there. Go to the EPD Australasia website and you'll find it. Here's a few screenshots to give you some idea of the information that's inside. And I'd just like to thank Elise for your time and to open also up for questions. I've got a few that have already come in. They're all for you, Elise, so far, and I think some of them came in before some of your key learnings, but I'll put them to you anyway. First one is, considering how big the project was, would you do it again?
Yes, but it may be because I must like to punish myself in some weird shape or form. I would do it again. I think it was worth it for what you really learn out of it and therefore the ongoing longer term opportunities that come with that. Yeah.
And I guess another question is, how much additional data collection was required as kind of the process progressed to actually complete the EPD? Was there lots of additional work in that last period of the EPD to get it all finalized, given how complex the product was?
I almost can say that, Jeff, you could probably answer that and say yes. So there was certain data sets that we could manage quite easily and quite well. There were some other data sets that we thought we hit the mark with the PCR, and then, thankfully we handed over to ThinkStep with their LCA lens and they told us, no, go back and try again because you missed this. So there definitely maybe the first and second pass of the data set almost seemed too easy and too good to be true. And it wasn't probably until we got to, I think it took us all up about 5 iterations of the full data set, which included refinement of the bill of materials, any simulated data that we did need to obtain from subsystem manufacturers if that was necessary, manufacturing data, and certain assumptions that we had to make. We had, in some instances with the manufacturing data, we had to assign an assumption based on, okay, well, this is their annual energy consumption footprint. We know that the manufacturer of our particular rolling stock typically occupied about 40% of their total factory space. So we did have to apply some percentiles for some gates of information. But yes, it was, to answer the question, yes, there was a fair amount of work required for the data sets.
Yeah, and from my perspective, certainly getting the use phase right was tricky because it's so important. We had to make sure we really nailed that down. Another question is, does it give you a market advantage having the EPD?
I think it does, in the sense that it shows not only our customers but also our shareholders that we value sustainability, we value being as transparent about that as possible, and it's definitely afforded us information that we never would have had before if we hadn't undertaken the process.
Great. And probably our last question, can I already ride on one of these trains? Are they already in service?
Yes, you can. Yes, absolutely. So if you're in Sydney and you see any train go past you that looks like the image that's on the screen, and it would usually have a decal on it that says 1 of 24, that's one of these trains. So yes, you can.
Brilliant. And with that, I'd like to wrap up. Thank you again, Elise. I'd also like to just give a little bit of a plug for our next webinar, which is on the Material Circularity Indicator of the Ellen MacArthur Foundation, together with Rob Johnson from Liberty One Steel. That's coming up on the 9th of April. So if you're interested in that topic, please go ahead and register. And just a quick thanks again to everyone who dialed in and to Elise for speaking. Really appreciated that. And thank you again, Elise, for your insights. So have a great day, everyone. Thank you and goodbye.